here weigh a certain amount, and it weighs basically more than the air. Okay? So if you actually take a look at it, because it weighs more than the air, it sinks, right? It's not buoyant. But we know a trick. We know a way of increasing the volume of the helium inside of that balloon. How can we increase the volume without increasing the pressure? Okay, you want to record this? Okay. Guys, how can we increase the volume without increasing the pressure? Well, what happens if you increase T? V has to go up, right?
Yeah.
Think about it this way. This was 1 over 2, right? And we doubled the T to 4. What would have to happen? The V would have to go up to what? 2, right. 1/2 is the same as 2/4.
Yeah.
So, if we increase the temperature on this, we're going to increase the volume. I have to be careful because I didn't actually set one on fire, but I kind of melted it. So what's happening here? As you're heating this, what's happening to the molecules? They move quicker. If they move quicker, they bounce harder off of each other. They bounce harder off the walls. What does that mean? Well, it means that they're going to have to get further apart.
Less dense.
They get further apart, less dense. Yeah, question?
No, I just meant to use the word.
Oh, you were doing the victory lap, better.
Yeah.
All right, so let's see what happens.
What's up, sir? What's up, dude?
Oh, still not. Okay, we got to kind of heat it up a little more. Might have taken too much out of it. What should happen is it heats up, it should begin to cause the balloon to blow back up. The molecules expand and the balloon should become less dense. And it wants to go up real badly, but it doesn't quite have enough. Of course, the other problem is probably that it's, as it floats up, it's beginning to cool off a little bit too. There we go. Oh, let's go. There it goes. What do you think's happening here?
It's not saying enough. The air temperature is cooling it off.
Yeah, once it gets up there, it starts cooling off pretty quickly.
Oh.
We'll just try one more. Let's see. How do we do if we don't have that? Okay, that's actually probably going to do it. I think maybe the extra weight was causing a little bit of a problem. We may have taken a little bit too much out of it.
Sorry. Yeah, that's what we done. Take it back in. Yeah.
Well, it wants to flow. You can tell it's a little bit more buoyant. What's happening is as it gets up there, it starts to cool off. So let's just actually try one more thing. Let's take a little bit more weight away.
There you go.
There we go. Let's try a little bit of weight here. I think we probably. Oh, we're having. That's pretty close to being neutral. I think we actually gave it too much of a positive buoyancy, so negative buoyancy. Let's try one more time. Again, what I think's happening is it's cooling off in the room pretty quickly. Boom. Okay. So, if you actually take a look at what's happened, we increase the temperature. This is the way hot air balloons work. You increase it. Hot air balloons, you can actually float a balloon with just plain air. All you have to do is heat up the balloon. If the air in the balloon is so hot that it becomes less dense than the air around it, it's going to float like that. All right, and you notice it's actually staying up there for a little while. It's going to stay up there until the air inside the helium inside the balloon begins to cool down, begins to condense a little bit. Once it condenses, its density increases, and it begins to sink back down like that. There you go. Okay, and I think